quadrilaterals. I'll give you some notes and we'll go through a couple of examples. First thing, inscribed triangles. Sides must be chords. When we say inscribed, we mean that the triangle is drawn wholly within a circle. All the angles still sum to 180. It's still a triangle after all. But typically we're only concerned about inscribed right triangles. What does that mean, you say? Well, right triangles are popular. Why? So if we look at this, you can see, hopefully, right there, that is the center of this circle. What that means is that AB is a diameter. Now, if AB is a diameter, just like the dog gets fussy about things, that would mean that this arc here, this major arc here, is 180 degrees. Why is that important? If you look, angle ACB is an inscribed angle. It's formed by those two chords, which means it must be half of that 180 degrees, aka 90 degrees. That then means that the other two angles, right, if 90 is taken up, the other two angles must add to 90, just like a normal right triangle. Key thing, one of the sides is a diameter, and you can tell because typically they'll put the center in there. Inscribed quadrilaterals, same idea, a quadrilateral drawn wholly within a circle, such that the sides must be chords. It doesn't have to be any particular type of quadrilateral. Could be anything, nothing going to be particularly special. Opposite angles sum to 180, and here's why. So if you're looking at this, we indeed see that this is wholly drawn within, meaning that if you look carefully, like if we take a look at angle B right here, right, angle B, that is an inscribed angle that subtends this arc here. Great, you say. Big deal. Well, take a look at this. If we take a look at angle ADC, and I think you'd agree that they're opposite each other, it subtends, well, doesn't that look like the rest of the circle? Which means altogether, the green plus the red has got to add up to 360 degrees. So that would mean that the measure of arc ABC plus the measure of arc ADC would have to equal 180 degrees. And then we know that angle B and angle D. Well, what do we know? We know that the measure of arc ADC is really 2 times angle D, and the measure of arc, I got that reversed. Switcheroo. The measure of arc ABC is 2 times angle D, and the measure of arc ADC is 2 times angle B. These are really the same thing, which means when I add them together, I still get, sorry, this should say 360, not 180, 360. If you'll notice, I can divide everything by 2. Let's do that a little bit more neatly. Divide this by 2, divide this by 2, and divide this by 2. Then I get the angle D plus angle B equals, well, 360 divided by 2 is 180. You can make a similar argument for angle A and angle C. So, examples. Inscribed triangles. So if we look, we can see because of this center point that this is a diameter, which means that this angle right here is a right angle. And if we wanted to figure out this other angle, then we know that that other angle is going to be equal to 90 degrees minus the 23, which is 67 degrees. Similar reasoning, because this is a diameter, and it subtends then that arc there, that makes this 90 degrees, which means that the other question mark here is equal to 90 minus 35, or 55 degrees. Inscribed quadrilaterals. If you know one angle, then you can find, well, there's the opposite angle. How? Well, we know that that is equal to, well, because they sum to 180, 180 minus the 57, 180 minus 57 is, of course, 123. Similar logic. Now, you could remember that all the four angles in a quadrilateral add up to 360 and subtract everything, or you could just say, hey, I happen to know this, and so that would mean that question mark is equal to 180 minus 107, which is, well, how much is that? That would be 73 degrees. Similar logic, 126 plus what is equal to 180? So 180 minus 126 would be 54 degrees. And conversely, this 87, which is opposite this question mark, would be 180 minus 87, which is 93 degrees. And that's it.